Hello guys, welcome back. Let's solve day 3 challenge, which will be to sum challenge, and it's a popular question. And we are told, given an array of integers nums and an integer target, return the indices of the two numbers such that they add up to the target. Let's say for example, we have an array that we have these numbers 2, 7, 11 and 15, and the target is 9. We are told to return the indices. That is, let's say for example 2 is at index 0, 7 is at index 1, 11 is at index 2, and so on and so forth. So we are told to return the indices, that the two indices that when they add up, they will add up to the target. 2 and 7 are, when they add up, we get our target 9. So we return the indices. And for example, in an array 3, 2, 4, the target is 6, and the indices that we return are 0, then 1, 2, because the 1 and 2 are the indexes that when they add up, they return 6. So let me explain how we are going to solve this question. Say if we have an array that is that has numbers 2, 1, 5 and 3. This is our array, and the target is equals to 8. Let's see how fast we can use brute force to see if we can find the answer. But there's a more smarter way to do it, but I'm going first to explain the brute force way. Brute force is just the same as the previous video. We are going to check if 2 and 1, let's say 2 and 1, when we add them up, are they going to add up to our target? If no, they don't add up to our target. Let's go to 2 and 5, then 2 plus 5. Do they add up to our target? Doesn't add up to our target. So we are going to do that till we get to the end of the array. Then if this is 5, it doesn't add up to our target, which is 8. So next we are going to go to the next number. We have seen all the combinations of 2. Let's see the combinations of 1. So 1 plus 5, this is the brute force way. 6, no, it doesn't add up to our target, and so on and so forth. Then we come to 5. 5 plus 3, yep, it adds up to our target. So we return the indices, which is the indices here are 0, 2 and 3. So we return 2 and 3 as our answer. But we know that this solution there's a more smarter solution that I'm going to explain. The clever way to do it, we are going to initialize first an empty hash map that's going to take in a key value pair, and we are going to map, let's say for example, each element to its corresponding value. Let's say 2 to the index of 2, it will be at the 0's index, then 3 will be at the 1's index, then 7 will be at the 2's index, and so on and so forth. So the clever way to do it is, first initially our hash map is empty, and what are we looking for? We are looking for combination where two numbers, when we add them up, they are going to give us our target. In this case, our target is 11, and to find the two pairs, we can simply minus, let's say for example 11 minus 2, and we know that 9 plus 2, because 9 combination that can be used with 2 here is 9 to find 11. So we are going to find the difference of the numbers and check if that number is in our hash map, which is initially empty. So we are going to first start at the first element, and we are going to take our target 11 minus 2, and we find that the answer is 9. But 9 is not initially in our hash map, so we are going to map 2 to the index. So 2 and its index is at index 0. Then next we are going to go to the next number because it's a for loop. We are using a for loop to go through all the numbers, checking every combination. 11 minus 3, because that's the combination needed. That's 8, and we see that 8 is not in our hash map here. It's not here, so we are going to map that number to its corresponding index. It's at index 1. Then we're going to check the other number, 11 minus 7. The answer is 4, but initially we don't have 4 in our hash map, so we are going to map 7 because it's the element, it's the key, to its initial index, which is 2. Then we're going to continue like that. Then let's check for the next number, our target minus our element. We are here now, 4, and we find that 7. We find that 7 is in our hash map here, and its index is 2. So we have found a combination of that 7 plus 4. This combination can give us our target, which is 11. We can now return the indices, which is 2 and 3. Let me code this up. Okay, so this is the coding solution. First, we're going to specify our license as usual. License identifier. Then our Solidity version, Pragma Solidity 0.8.18. Then contract as usual. Today we are at day 3. And then first of all, we want to specify our state variables. Our state variables, first of them is the mapping of, that is to the mapping of the key to the value, which is a uint, and a uint is going to be eternal. Okay, it's eternal. And this is the mapping. You can call it just a hash map. Then next is the answer, which will be also internal, because I'm going to create a getter function, and this will be the indices we are going to return. Then we can use a modifier to check that it's going to take in memory array. This modifier we're going to, the name is check length. Modify. We're going to check that we're going to require that the array dot length is greater than or equal to 2, because if it's not 2 elements, it's not an array, so not an array. So that's it. I don't know, I am getting this error. Modify. Oh, then next, our function is toSum. Yep, it takes in a uint memory array. It's public, returns. We're going to use our modifier. It returns an array. First of all, we are going to use our for loop because we want to go through all the numbers in the array starting at location 0, and I must be less than, okay, let me just specify it because we don't want to keep asking what's the length of the array while the loop is running. So unit length is equals to array dot length, and we can just check the length once and keep on going. Okay. Okay, first we are going to get the difference, because the difference will be, if the difference is in our hash map, we have found the answer. So unit difference is equals to target, and I've not specified my target here. It's going to take an array and unit target minus array at location I. Then if in Solidity there is no null, everything is, if it's not yet specified, it's set to 0. Our hash map at location diff, if the difference does not equal to 0, this checking if already we have added difference, the number, to our hash map. Okay, if that has happened, we can specify that the indices is equals to hash map at location difference, comma, and at location I. Then we're going to close that. Otherwise, if we have not, if the key is not, if the element is not in our hash map, we can add it to our hash map, because we know there should be one answer. So let's add it to our hash map at location array I equals to I, and that's all. We need to create get a function. So get answer, and it's public view returns. It's going to return the answer, the indices. So it's uint 256 to insert memory and return indices. And I think we're done, compiled successfully, and let's deploy this. Let's deploy it successfully. Okay, let's give it an array. Let's say, for example, 1, 2, 3, 4. We know that the answer, let's say the target to be 7, and by our naked eyes we can see that 3 and 4 will give out 7. But the index of this, once we run that, it runs successfully. The index are at 2 and 3. I hope you can see that right. It's at 0, 1, 2. 2 is at 3 is at index 2, because we start counting at 0 in an array, and 4 is at index 3. So until next time, see you, have a great day. Subscribe to the channel if you are loving this challenge, and if you are gaining something out of it, Thank you very much. See you next time. Peace.